So hello everyone, welcome back to the channel and you're watching Komal Taya. So guys, in the last videos I talked about the previous year questions only, and in this video also I'm going to take previous year question of CSIR net chemical sciences, right? So the question which I'm going to take, it's very important because it came in December 2011, right? So just be with me till the end, and this question is very important, so just pay attention to it, and it will be regarding like the statement wise question, that first order perturbation and the second order perturbation, similar, little bit similar to the last question which I discussed in one of the videos, right, or second order perturbation. So let's just see how this question looks and how this goes further, right? So the first question which you can see over here is this one, CSIR December 2011, 7th question. Clear? So this is the 7th question, and according to it, it is given for non-degenerate perturbation theory for ground state with E naught as 0th order energy. So this is 0th order energy, right? And E naught 1 is the first order perturbation correction. Fine. So now instead of writing this, they have given it like this, E01 only. Just pay attention over it, guys. Instead of this, they have given this, and this is this one, the ground state original one. Fine, the ground state energy, that is E00 only. Fine, and E0 as the exact energy. So this is the exact energy. Fine, and we need to find which of the following is true. Fine, so it is basically statement wise question only. So we need to find whether this A option is correct, that E0 plus E01, that is this original value plus this first order perturbation. I'm writing FOP, or first order correction, FOC. This first order correction and original value is always equal to E0, whether it is true, or E0, this original value, plus first order correction, it is less than, means it can be less than E0, that means exact energy. It can be less than or equal to. Fine, so whether this statement is correct, or here it is greater than, equal to means it can be equal or greater than, and here it is something else, that it is original, and this is something they have given one order, that original will be less than equal to this. This is exact, and exact will be less than equal to first order correction. Fine, so you all must be confused that what is the correct answer, right? So let me just tell you this thing, that you all know that this thing which we have seen in the question, that original value plus first order correction is equal to exact value. Fine, that I have told you, that original value plus energy correction value, that is equal to exact value. Fine, I told you many times in the first order perturbation that if energy correction is given, that will be different thing. If exact value is given, that would be different thing. So people who are new, just go back to my first order perturbation classes and see what I have told there. Fine, so it will be like this over here. So according to it, question can be this also, or this also, or this also, because we don't know that it is equal, greater than, or less than. Fine, so let's see what is the main thing over here. So I have solved the question over here, so I'll be telling you by taking some examples, right? Okay, let's take one example. Fine, so what is basically perturbation? Tell me. Perturbation means, suppose if this system is given, so this should be ideally this system should be like this. So if this is perturbed by this part, that means it is perturbed. Fine, so if I have to find the exact value of it, so I will find that whatever the original value will be plus correction will be, like whatever the correction will be plus and original value, correction plus original value. Fine, so guys, suppose if this is not perturbed, fine, if perturbation is 0, that means perturbation 0 means, are you getting? If I say if perturbation is 0, perturbation in the system is 0, that means the system is ideal. That means this system is like this only, no perturbation. Fine, so my exact value will always be equal to original value. Please tell me. This will obviously will be 0. correction, energy correction, we always talk about energy correction only when the system is perturbed. If perturbation is 0, that means system is not perturbed. System is not deviated. System is as it is. System is ideal. So that means whatever energy earlier would, suppose if someone is saying find the kinetic energy. So kinetic energy for particle in 1D box. So that would be n square h square by 8 ml square. Fine. N square h square by 8 ml square for 0 to L length box. Fine. So what will happen? Fine. If that system is perturbed, so then this n square h square 8 ml square original value plus energy correction, whatever perturbation will be given, you will find the energy correction and then you will add it over here, then you will find exact energy value. You know that. That's how we used to do the first order perturbation. People who are getting confused, please go back and see those lectures again. Fine. So this is a little bit confusing. Clear? So what will happen now? That if this perturbation is 0, this can be equal to this. But if some value is over there, some value is over there. So obviously this value, if this value is negative, fine. So this exact value can be, obviously, if this value can be negative or positive. Now the whole thing can be like this can be equal to original also. This can be equal to this original value also. But plus if system is getting perturbed. Now I'm saying earlier I took a case when no perturbation is there. But now I'm taking suppose a perturbation is there. I have to take all cases, right? When no perturbation is there, this value will be equal to original value. But if perturbation is there, obviously energy correction will be there. It will be having some value. It will be added up and now E exact will come. But we don't know that delta E would be negative or positive. Fine. But suppose if original minus negative will be there, so E exact would be low, obviously. Fine. But if positive is there, it would increase. E exact would increase. Fine. So now we have to generalize that whether this energy correction is positive or negative. So now we'll take some examples which we discussed in the previous questions in the last videos. Fine. In the latest question only, tell me, the last question which I discussed in the question, this one, remember? In this question where I told you that the perturbation is in terms of alpha x. Fine. So when you calculated it that E naught 1, the energy correction in first order energy correction, was this alpha x and it came out 0. Guys, for people who are new, please see, I have discussed this question only in the earlier lecture. So see that lecture. Fine. So that came 0. Fine. So guys, what I am generalizing here, that here the delta is 0. Like the formula can be this only, that psi, suppose it is 0, so it would be 0 delta h psi 0 dx. Suppose I am taking 1D. Fine. So now what will happen? So this delta h, what we have seen delta h in various forms. We have seen alpha x. Fine. We have seen alpha x, right? So now we have seen alpha x. Sometimes we have seen alpha x cube. Fine guys. Sometimes we have seen delta h is equal to v by 2. Remember that guys? Remember, suppose it is v by 2. Fine, if delta h is v by 2, I am just taking one example and particle in 1D box is there. Particle in 1D box is there. Clear? And I have to find between 0 to L length box. 0 to L length box. Clear? So now what will I do? 0 to L length box, psi naught, delta h is v by 2. Clear? And psi naught dx. So now this v is constant, so I'll take v by 2 outside and it would be 0 to L psi naught dx. So now this time it has become probability. Probability, you know that how to write probability. Probability means psi naught, like anything psi dx. You know that. Fine. Then it has become psi dx. So it has become probability from 0 to L. Obviously that would be 1 only. That would be 1 only. In the whole box particle will be there, so probability will be 1 and answer would be 1. So always in this example where perturbation was in terms of alpha x, this term, when I take out alpha, the whole expression became in terms of average value, and when I took this one, this case v by 2, the whole expression became in terms of probability. So people who have solved the first order perturbation question, so you must have noticed that either the last expression becomes in terms of average value, like in this case, or in terms of probability. You always solve like this only, the first order perturbation question. You always solve that it always come down to two things: either average value, it is delta x or px or kinetic energy, or in terms of probability like this. There are two examples. Here I have taken this perturbation, here I have taken v by 2 perturbation. So here it is coming in terms of average value, here it is coming in terms of probability. So probability will always be positive, you know that, fine. And average value, we have never seen that average value is coming negative for any system, right? So what we'll do that this thing is positive, energy correction is coming positive. Sometimes it can be zero also, like this. In case it became zero, but if it is probability, it can be positive also, fine. So we are going to generalize the thing according to the question we discussed. So in one question it became positive, in one question it became zero. So first order energy correction can be either positive or zero. It is generally positive. In most of the cases it is positive, but it is not always positive. Guys, this question, only this statement has been molded so badly most of the time that people get confused. I'll tell you in the next example also, in the current example also, and in the next example also, how equations get molded. The next question is a little bit different. So for this question, I'm telling you the first order energy correction can be either zero or positive or zero, fine. And in the most of the cases it will be positive. Just star mark this line, just underline this line, just cram this line. What I am telling you, this is very important, very very important, that the first order energy correction can be zero or positive, fine. And generally it is positive. So guys, if I come down to this the answer basically, so what happens that E0 defines exact, and E01 defines first order, and E00 defines original, fine. So if I write original plus first order, it is always the combination original plus first order correction, fine. Original plus first order correction, and it has some relation with exact. We don't know it is greater than, equal to, or what, fine. So what happens, original is the value which we get, suppose it is kinetic energy, then for particle in 1D for 0 to L length box, so it will be n square h square by 8 ml square, plus first order correction. I told you it can be either average value or probability, so they are always positive or zero, fine. So if it is zero, then original value will be equal to exact value, fine. Original value will be equal to exact value, right? But what happens, but if this first order correction is positive, that means it has some value like v by 2. In some of the example I discussed in the last videos, you must have seen the answer is v by 2 or like that, fine. So it will be greater than the exact value, fine guys. It will be greater than the exact value. I hope this thing is clear to you, because it is positive, so obviously it will be greater than the exact value. If it is zero, suppose if it is zero, it will become equal to exact value. But first order correction is I'm just telling you, if it is zero, the original value will become to exact value. If it is positive, so what will happen, this entity will become greater than exact. So if I have to write in combined manner, so I'll write original plus first order correction will be greater than equal to exact value, fine. The exact value, whatever it is asked. So original is defined by this thing E00. So what I will write, E00 plus first order correction. So first order correction is defined by E01, fine, and greater than equal to E exact. So these things are given in the question, right? So greater than equal to E0. So this is the answer, and this will be the answer, and it will be matching with C part. So you can see over here, I'll be just showing you guys. So if I just so it will be C part, where you can see it is original value Fine. And this is first order correction, and this is exact value. I hope this thing is clear to you guys, and if you have any doubt, please feel free to leave the feel free to use the comment section, leave your query in the comment section, or you can join my Telegram group. You can just put your doubts over there also, right? So I guess that's it for this one. I'll see all of you in the next one. Till then, bye, take care, and keep smiling. Bye.